Right, good afternoon, ladies and gentlemen. Today, let's go to the first lecture of the introduction of the chemical engineering. So, in the beginning, let's think of what is chemical engineering. There are a few answers, and then please make a decision to choose which one is right. The first one, and the second one, and the third one. So which is the right answer? The answer is none of the above. Why? Because for these three choices, some of they are partially right, but it's not 100% right. Why? Because we have a definition for the chemical engineering. So the definition of chemical engineering is non-universally accepted definition of the chemical engineering exists. And most every type of the skill works you can think of is done somewhere by people educated as a chemical engineers. So there's no universally accepted definition. So there is no exact definition of the chemical engineering, because chemical engineering involves many things. I will tell you this more details in this lecture. So, okay, so let's think of what is chemical engineers. So again, there are a few choices. First one, an engineer who manufactures chemicals. Okay, the second one, a chemist who works in a factory. Third, a glorified plumber. So which answer is right? Again, the answer is none of the above. They are not these three choices are not 100% right, but they are partially right. Okay, so what is chemical engineer? Okay, the chemical engineers are comfortable with chemistry, but they do much more with this knowledge than just make chemicals. So you have a lot of knowledges. The one of knowledge is to make chemicals, but this is not all. The second one is the chemical engineer is meant to reveal what makes the field different from the other branch of engineering. So you have mechanical engineering, you have electrical engineering, you have civil engineering, you have information technology engineering. So you're different. You are the only one who studied chemistry. Well, so the breadth of the scientific and technology knowledge inherent in the profession has caused some to describe the chemical engineer as universal engineer. Universal engineer in Mandarin is 全能工程师. Okay? So this is the very special, you are a very special engineer who use chemistry knowledge, chemical knowledge to solve the problem. So now an engineer, apart from the chemical engineering, now I'm an engineer who use knowledge of chemistry to solve the problem. Okay? So you are highly linked with chemistry. Okay? And then, so because chemical engineers can use many raw materials and convert it or change it to the products. So, and then to make products, very good. So some people call chemical engineers as a universal engineers. Okay, so let's go back to the engineering and science. What's the differences between science and engineering? So there's a dashed line here to tell you the difference between science and engineering. So the way of the thinking is different. Okay, in terms of science, you need to have a creativity. You need to have a scientific knowledge, and you want to find out the phenomena or mechanism of the materials or some kind of the principles. And after you realize everything, you can use this for discover the new phenomena or to discover new materials and the mechanisms. But in terms of thinking, in terms of engineering, you need to think of production. Okay, so the production is very different from the science, because science, they don't make production. So in terms of production, engineers need to think of how to design the process, how to do the operation, how to make it works using cheaply. Okay, and also you need to think of ethic for this technology to use in a society. So engineering way of thinking is very different from scientific way of thinking. And also, what's the differences between chemistry, which is in engineering, science department, science college, and engineering, chemical engineering is in the engineering college, right? So what's the difference between chemistry and chemical engineering? Again, chemistry, chemists, they learn a lot of chemistry, of course, like organic, kinetic, and analysis, chemical analysis, and make the materials. However, for a chemical engineering, they need to work with the production. So they need to have a big scales, like you need to think of the processes. The process in chemical engineering, we call it unit operation. And not only unit operation, but also you need to think of the processes to make a mass production. Like you have to design the process, you had to know process engineering, you had to know the safety, you had to analysis whether this process can works and make money or not. So let's make an example, which is different from chemistry and chemical engineering. I hope you all know that penicillin is a kind of antibacterial material, medicine, right? This medicine is, in Mandarin, we call 抗生素. And this medicine is found by chemists, okay? And then the Fleming, he found these materials, but he didn't know how it works. But after a few years later, Florey, professor, he found that this is antibacterial medicine. Okay, so it can work to help people as a medicine. However, penicillin at that time is very expensive. Not everybody can use this. So only rich people can use this medicine. Okay, because you cannot do a mass production. You cannot have a lot of penicillin for everybody to use. That's why it's expensive, right? So this is a very important example, is that in the Second World War, this is the poster saying that thanks to the penicillin, he will come home. Why? Because a lot of soldiers die is not because in the combat, it's not in the battle. They die because they're injured. And then they send it to a hospital and they use penicillin to let it survive, to let the soldiers survive. So if penicillin is very expensive, not many people can use it. This soldier will die, right? Okay, so you need to think of a mass production way to let people survive. Okay, at the old time, if you use the way of the chemist thinking, you have to make a batch productions. This is the way to make penicillin at the old time. You know, you have a lot of beakers, and then you use this what we call batch production. So how many of these is 300,000 beakers, and you need to shake these beakers, and you need to use a lot of people to work on this to to put it, to add something and to remove something away and to make penicillin. That's why it's very expensive. Okay, so this is a very tiring work, but this is the way to make penicillin in terms of mass production. Is this the right way to do it? No. For chemical engineers, we need to think of how to do the mass production with a cost-effective way, and the penicillin will be very cheap. Okay, so this is the kind of process. If you have raw material put into the process A, process B, process C, process D, and process E, and in the end, you come out with penicillin. And you can make the process line go through this, and then from raw material to products. And in that case, you can make a lot of penicillin with a very cheap price. I'm sure at this moment you don't know why is this, why is process A, why is process B, why is process C, for example. But don't worry, this is what we call unit operation. You have a process, you make a processes together, and you have a raw material in and product out. Okay, this is what we call mass production. This is what chemical engineers need to learn about these processes. Okay, so for the mass production line of the penicillin, you can think of this. You don't need to have many workers to work on the factories. You just have raw material in and a product out. Okay, this is what we call mass production and made by chemical engineers. So if you want to make a mass production, of course, you don't do it, you don't think of it, and you don't work it. You don't make a mass production. Of course, you need to have from the laboratory scale to the pilot scale test, and then to the a bigger pilot plate scale. And then you need, before you make the factory, you need to have simulation. You need to do the simulate the process, and then once you find out it will works, and you start to build a factory. And once you build a factory, you start to do the test, and after test, you do the production. So this from lab to the production is not just like 0 and 1. You just think of it and just make it. You have to go through this from small scale, medium scale, and simulation, and then build your factory. Okay, so just now I gave you an example of the importances of the chemical engineering. So let's think of let's think of the beginning of the chemical engineering. You know, at the old time, this is a crude oil, and then in about 2 centuries ago, the discovery of crude oil, nobody knows what to do with crude oil, because crude oil is a kind of energies, it's kind of materials. So at that time, nobody knows how to handle crude oil. So Dwark, the first American who successfully drilled for crude oil. So crude oil is a very complex set of the molecules. Okay, you can have many type of molecules from crude oil. So you need to have a refinery process, okay, to separate these materials. So refine these molecules into a liquid and gases are of use in society. So you want to use this crude oil to separate into A product, B product, C product, D product, and to use them in a society. So at that time, there's no engineers can work on this. Can you ask this? Can you ask electrical engineering to work on this process? No, because they don't have knowledge of chemistry. Okay, can you use mechanical engineering to work on this? No. Okay, so at that time they think, wow, we need a group of the engineers who knows the chemistry and also who knows the mass production process to work on this project. So chemical engineering is to conversion raw materials into a variable products. Okay, so in the beginning of the chemical engineering is to try to solve the problem of the crude oil and to get from the raw material to the variable products in liquids or gases. So the origin of the chemical engineering is that this is the founding father of the principles of chemical engineering. So George Edward Davis, he's a British. Okay, he made the earliest analysis of chemical engineering on record. Also, he did this first in series of lectures on chemical engineering in 1887 in England. Okay, and also he published a handbook of the chemical engineering in the beginning of 20th centuries. Okay, so he's the founding father of the principle of the chemical engineering. So where is the first lecture or first course in chemical engineering? Was offered at MIT in United States by a professor of the industrial chemistry, Louis Mills Norton, in 1888. He called it Course X. You know, the world's first 4 years chemical engineering curriculum. Okay, right. So, and also the first department of chemical engineering was started at the University of Pennsylvania in 1892. Okay, so this is the origins of the chemical engineering. So what kind of knowledge you need to learn from in a chemical engineering? You know, you need to learn the basic science like math, physics, chemistry, and biology. And also you need to learn something which is special courses for the chemical engineering, like unit operation. This is process. And I'm not talking about the process in a laboratory. I'm talking about the process in a factory. So you have a big scale. Okay, and this is transfer phenomena, including momentum transfer phenomena, mass transport, and heat transport. And also you need to learn thermodynamics and also chemical engineering kinetics. Okay, right. Next is that 10 achievements of the chemical engineers in history. You know, the chemical engineers, they found the atoms, plastic. You know, plastic, you know that you can use, now you use the plastic every day, right? And artificial organic organs, right? Like artificial hearts, right? Artificial lungs. So this is called ECMO, right? ECMO, 叶克膜, right? Okay. And also you do the mass production of drugs, medicine, right? And artificial fibers. Okay. And liquefy air. Okay. If you have a liquefied nitrogen or oxygen, this is called low temperature engineering technology. And also you have a kind of technology to make better environment. Okay, one of the example is catalytic converter for a car. Okay, food. Okay, chemical engineers, they invent fertilizer, right? So you can have a lot of fertilizer to make food. Okay, so and that's why you have a lot of you can do the process of the food. Okay, so that's why you can ensure a lot of food provided for the human being. Okay, and next one is crude oil. Remember crude oil. And also artificial rubbers. You know, artificial rubbers for the shoes, tire, pipes. Okay. So these are very important for the human being, and modern human being to use. Okay. Thanks for the chemical engineers. Okay. So that was in the past. So what's the future? So today's chemical engineering is that, you know, chemical engineering or chemical engineering process industry involve many type of the directions. Okay, so it's related to our daily life. So again, I want to tell you that the scope of the chemical engineers is to get the raw material, right, like crude oil, and then to convert it into many different type of the intermediate products. Okay, intermediate products. And after intermediate products, you can make some kind of chemical products. Okay, you can make some kind of materials for human being to use. So for the chemical engineering industry, we can divide it into a few parts. This first part, oil. Okay, oil products, and these advanced materials like integrated circuits, manufacturing of integrated circuits. Okay, and PCB and liquid crystal and LED. And another type is biotechnology. This is biomedical technology, right? This is process engineering. And for the energy, and for the green chemistry, and the nanotechnology, and industry. So for chemical engineers to work in the chemical industry, is involved in this few industry. Okay, let me explain this one by one. For this is that for the crude oil is actually is that, you know, you have crude oil, and from crude oil you make pure molecules products, right? And then you can make it to a different type of the final products. And also the artificial fibers is that you can make different type of the clothes. For example, if you have hollow fibers, and you can make a super fine fibers, and you can make the fibers with which cannot be burned easily. Okay, so the advanced materials can also, this is one of important industry in Taiwan, right? Okay, one of example is IC production. You know, from the silicon ingot, silicon wafers, and a lot. You do the IC process. You make a lot of IC chips, right? This is one of the important industry in Taiwan, like TSMC, UMC, right? So you need. I'm sure that many of you will go to this industry after you graduate in Taiwan. So this is fab, what we call fab. The fab is to manufacture wafers. Okay, and if you look at the details of wafers inside, under the observation of microscope, you can see a lot of this kind of circuits. Okay, another example of the advanced material is liquid crystal. Okay, so this is an example for your information. Okay, next one is biotechnology. The biotechnology is very important because the 21st century biotechnology also play important role. So let's think of the process engineering. You know, human beings like a small biology factory. For example, like your heart is a kind of pump. The pump is a kind of input and output of a liquid, right? Okay, so this we learn pump. Okay, the heart is a kind of pump, and your lung is kind of exchange of the gases, the gas in and gas out. Okay, and your liver is a kind of reactor. Okay, and your vessel is a kind of pipe to deliver your blood, right? Okay, for the pipe you deliver liquids, right? But for the vessel you deliver bloods. Okay, and then for the kidney is a kind of filter. Okay, you learn filter you will learn filter in the course of chemical engineering. Okay, and also you have a reservoir to keep the water, right, or to keep the things. Okay, container, right? So you have a CPU, you have a brain, this control system. Okay, so if you link this is one process, but you need to make this process all together. So this is how you learn in the chemical engineering. Okay, so like ECMO, right? So for the chemical biological process engineering, you have a biological reactor. You can use the biological process to treat the wastewater, right? And this artificial heart, artificial cells. Okay, and so the chemical engineers will handle the artificial organs, right? So next important topic is for the chemical engineering is energy. You know, energy like fuel cell, battery, solar cell, and biomass. These are all the energies. Okay, you can energy technology you need to think or you will handle. And others is green chemistry. Green chemistry is that you don't the chemicals you use is all made from the very clean production, or this is called zero emission. Okay, zero pollution. So the chemical you produce is with the process of zero emission and zero pollution. That will be the very important process in the future. And finally is the nanotechnology. You know, nano is that the materials, the dimension of material is less than 100 nanometer in one direction. Okay, so you can make this involve all the technologies like particles, like polymers, like hybrid materials, like any nanotechnology applications. Right. So as a chemical engineers in the future, what do you need to study to become a good chemical engineer? So this is a study in chemical engineering. So you need to combine scientific knowledge and also technical knowledge. And once you have the knowledge of scientific knowledge and technical knowledge, you make it together, become a chemical engineering. To design, construction, and operation in a safe and economical fashion. And after that, you have products. This is a perfectible manufacturing process. Remember, it needs to be perfectible. Okay? So what are the scientific knowledge? Like mathematics, physics, chemistry, biology, I just told you, right? So technical knowledge is transport phenomena, thermodynamics, chemical reaction engineering, engineering mathematics, electrical engineering computation, bioengineering, process control and design, and analytical chemistries. This is what you need to learn during these 4 years. Okay, including scientific knowledge and also technical knowledge. So this is the study map for you as a chemical engineer in a department. We have what we call the cornerstone. Cornerstone is very foundation knowledge, right? As I just told you, this foundation knowledge is cornerstone, and this keystone. Keystone is the knowledge you need to learn and to involve for the applications. Okay, as I hope you still remember this: biotechnology, advanced materials, chemical processes, environmental technology, and energy technology. These are all involved in chemical engineering. So, as a sum, you need to learn the lecture. You need to get courses from chemical engineering department. You need to get course from the chemistry department. You need to get course from the mathematics department. You need to get course from the physics department. You need to have some knowledge from the electrical engineering department, and also information technology department, mechanical engineering department, and material science. And also you will learn something related to environmental science. Okay, and also biochemistry. So chemical engineers is like orchestra, right? So you have chemical reaction unit, you have physical operation unit. So chemical reaction unit involve this, and the physical operation unit involve this, and you put this all together. So chemical engineering is involved physical operation unit and a chemical reaction unit. Okay, it looks like orchestras. Each one has its role, and you need to make it together to make a nice music. Okay, it's like human being body, right? So that's why we say chemical engineers is a universal engineer. Okay, because once you graduate from chemical engineering, you can go to work on the different areas like electrical engineering, chemistry, environmental engineering, material science, physics, and biological engineering. Okay, and medical engineering. And apart from technical, if you want to go to master degree, probably you can go to you work to the government, you work to the law, you go to law school to do some studies. So there are many directions you can go after you graduate. So this is after you graduate, what's your future and what kind of occupation you can have. So this is the salary you can get after you graduate in United States. The highest salary, this is the degree. What's the degree worth? Is that what kind of degree you get in order to get big money. The first one is chemical engineering. Okay. The second one is computer engineering. Of course, if you think of the computer engineering in Silicon Valley, the price, the salary will be higher than this. But we talk about general. Okay, we talk about general things is that in the United States, chemical engineering got higher pay than computer science, computer engineering. Not specifically in Silicon Valley, of course. Okay, and electrical engineering, and mechanical engineering, and computer science, and others are not engineering. So engineering got higher pay. Okay. So where do you work? In Taiwan, this is the this is the information in the United States. Okay, and this is information in Taiwan. So mainly, some of you, many of you, I should say, will go to electrical industry, and some of you will go to crude oil industry or plastic industry. Okay, and some of you will go to the pharmaceutical or biotechnology industry. Of course, some of you will go to the academic. Okay. So this is the information. And of course, your salary increase once you work for a period of time. Your salary will increase. Of course, some of you will change to another studies like business school. Of course, most of you go to stay in the chemical engineering, but some of you go to another school. So after 4 years education as a chemical engineer, you can go to master's degree, you can go to doctorate degree, and eventually you become engineer. Okay, or you can just go to law school, you can go to business school to do your master's degree, and of course you can also work as an engineer. Okay, this is one direction. So after you work as an engineer, if you like to study research, if you like research, you will go to expert, you will go to consultant. Okay, but if you work for a period of time, you might become manager. Okay, you promote higher and higher and higher. So these are the directions for chemical engineering. However, if you move to the business school or law school, you might want to go to a different industry or different business areas. It's all up to you, right? So in the end, I think it's important to know what you like. After 4 years education, you want to go to master degree, or you want to go abroad for studies, or you want to go to industry to make money. Okay, but the important thing is you need to work hard. You need to enjoy these 4 years in the chemical engineering department. Okay, so this is lecture today. I hope you enjoy the lecture, and I will see you in the next lecture.